Okay, geographers, today we're going to fight crime. We're going to keep people safe through our GIS skills and learn how to really, it's not about crime. It's more about statistics and spatial statistics, but we'll use crime data to learn that stuff because it works pretty well for the concepts that I want you to be familiar with. So we're going to get into that. And I'll admit to you right off the bat, when it comes to criminal justice, administration of justice, these different terms that we have to, for the major at a college that you, study to become whatever, a cop, a parole officer, these kinds of things. It's not my scene. That's what I'm trying to say. I have never taken a criminal justice course, but and that's a big thing with GIS. There's a lot of stuff that we don't study, but we need to have some kind of understanding of as we do our GIS stuff to it. So what I've done for today's video is I went through a book. It's called Crime Analysis with Crime Mapping by Rachel Boba. And it's one of these books that I got somehow years ago, like a publisher sent it to me or whatever to see if I'd use it for a class. And I didn't, but I read through that and used it to kind of get a sense of what people in the field of, criminal justice, the people who do this crime analysis stuff, how they think, what they focus on, and all of that. And it's a really good thing to do. This is kind of a bigger lesson for you GIS folk, is when you are working on a project in some field where you're really not an expert at all, when it's kind of out of your domain, find a book, go online, read some stuff, watch some videos, all of that, just to see what's important. Because what you might think is an important aspect of a study really isn't that important for the people who need your, need your answers or your maps or whatever that you're giving to them, right? You might also be able to avoid certain, mistakes, things that say this whole group of people who work in this field figured out decades ago, but you have no idea about that, right? So it's a good way to kind of ensure you're doing things properly. You're not doing kind of rookie mistakes, that kind of stuff. So we'll utilize her, but I'll utilize it. Maybe I have some statistical stuff that'll be on Canvas. Maybe I'll slap one of these chapters in here so you can look at it if you're interested in it. But that's the idea with this. And the things that we learn in this video series, these spatial statistics that we're going to get into, they work for mapping crimes and analyzing what's going on, but they also work with, other similar data, diseases, disease incidents. It can be, pollution found in soil samples or water samples, things like that, right? We can study a lot of stuff this way. And the thing is, if you're asked to do a study on something, but you don't know much about, disease and epidemiology, well, again, read up on that stuff. But what we're going to do here today is we're going to do some, to have my notes, we're going to do some strategic crime analysis. Sounds pretty awesome. I'm not going to lie. So, we're like Batman. And this is according to Boba in her book. This is the long-term approach to dealing with and preventing criminal activity. Okay, so that's the plan. Let's get ready, my Batmen, my Batmen and Batwomen and Batpersons. So we're gonna study crime and with the idea of hoping to prevent it in the long term. And typically, when I would do this, we would be looking at LA, Los Angeles County Sheriff's data or something like that. Instead, for this exercise, I grabbed some data this was from a tutorial that I didn't really want to do the tutorial, have you do the tutorial, but I grabbed the data from one of these Esri Press things. And so it's for the city of Pittsburgh. We've got this crime offenses data. So the red point features on my map, that's our actual crimes. The streets on here, just a reference point, not really necessary for exactly what we're doing, but it's something. And then this neighborhood data, let me uncheck. Here we go. These are different neighborhoods within Pittsburgh. And I left this base map on here. Usually I would get rid of all this stuff, but it's kind of interesting. I have no idea. I've never been to Pittsburgh. I have no clue, about any of these neighborhoods. Where's the good part of town, the bad part of town, all of this stuff. If we were working in LA County, for me, I can look at this stuff and you run some of this analysis and you go, yeah, that tracks, that makes sense. But what I like here is I have no preconceived notions about where crime is going to be, at its highest, where it's going to be concentrated, if it's concentrated, all of that stuff. So it's kind of, for me, I think it's interesting to run this as a complete outsider. All right, so I'm going to turn this on. I'll leave the streets off for now, but that's what we're doing. And I started a new map project. I just call it crime_stat, because it turns out I already had a project called crime for something else I did. But I have in Canvas, in the usual data spot, this crime geodatabase that's zipped and placed in Canvas. Download that, create your map project, get it all in the right spot. And that's where you'll get these three different feature classes. And these were already projected. Let me go in here just to see and confirm that I'm correct. Yeah, it's in this Pennsylvania State Plain stuff. So we don't have to go through our usual getting everything projected in the same projection exercise that we do. It was already projected. I figure we'll leave it there so we don't have to get hung up on all of that. So it's ready for analysis precisely because it's in this projected coordinate system. It's as good as it's going to get in terms of where it is located. Okay. Also, as we get going here, let's look at the data that we got. I'm going to right click and open the attribute table of our crime offenses. And what we've got, look at this. So what they said, here, let me move some names, or maybe if I just go to this, let's go, God, we got, geez, Louise. Anyway, well, look, here's the deal. I'm seeing there's some actual names of like someone who was drunk driving here. It said, when I got the data, that it was altered a little bit to keep it kind of anonymous and have some privacy and things like that. So I'm going with that. I mean, this is a published thing, freely available online. I feel kind of guilty. And I mean, you could say like, look, they're criminals. They don't, so what if they're embarrassed for driving drunk or whatever? But still, it just, I feel dirty just looking at it. This is why I never did the criminal justice stuff. Because I have too many feels. Okay, so ignore that. And we're going to assume that this stuff is not necessarily accurate in terms of, the location, the time, that stuff. It's really for training purposes, right? So I just give that caveat that I have no idea about what's accurate, what isn't accurate, but it's going to be useful. We have 11,500 records in here. So that's a lot of crimes, which is great for what we're doing. It's a lot of data, right? To actually derive information from statistics, all of that. And in here, we've got a lot of different criminal activity. Okay? There's this hierarchy field right here, and it goes from like 1 is actual murder. So the lower the number, the more serious the crime is seen to be. And that's kind of one of those things. You can look at how they set up some of these things. I don't know. Some of these things seem a little more serious than others, but again, c'est la vie. Not my world. This is just what we're dealing with. But with this, it's important to think about when we're dealing with crime data. What constitutes a crime? Are all crimes equal or some more severe than others? With this list, we're going to go through and we're going to get rid of some of these. And we're going to look for the more serious, more violent offenses, really more of the scary stuff, right? The kind of things where you're in a neighborhood where these crimes are happening, you don't feel safe. You're concerned for your well-being. Whereas some of these, like forgery, that's not great, but I don't live in fear of someone forging something next to me, right? But I don't want to be stabbed. That's the idea. So what we're gonna do is we're gonna start out with a definition query. Okay, so go ahead and right here. We can even close this for now. Right-click on crime offenses, and let's go into properties. And in here, our options, go to definition query. And so we're going to tell it. We're going to say, look, hey, computer, I just want to see these crimes. All right, so we'll do new definition query. So where, do hierarchy. And then our options here we have is equal to, and a bunch of things below that. But what we want is to get hierarchy value 1 through 8, basically. And anything 9 and above there, we're going to think of as lesser crimes. I forget exactly what 8 was. I already looked at this stuff. But it's assaults, it's murder, it's some of the more aggressive things that we're dealing with, and some of it is, frankly, some of the stuff it can get depressing. You don't have to go through and see every single crime and dwell in that kind of stuff, because I don't know, it bums me out. I don't know about you. If you're morbidly fascinated, have at it, but we don't have to dwell on the crimes themselves to accomplish this stuff. All right. But so what we'll do is hierarchy, let's say, is less than or equal to, and we can hit the drop down and it gives us all these, possible values. You could also just type the number 8, but I'll select 8. Okay. And this is when you're doing these queries, try to think elegantly with your, how you're putting them together. We could do hierarchy is equal to 1, or hierarchy is equal to 2, and kind of keep adding these clauses. But try to think, what's the simplest way to get what you are trying to accomplish? So hierarchy less than or equal to the number 8. So it's going to grab 1, 2, 3, 4, 5, 6, 7, and 8, and everything else will be ignored. Okay? You could hit apply here just to kind of get it in there. You could hit apply here if you want. I'm just going to hit OK. And what happens, might happen quickly, but a bunch of our points disappeared, right? Those lesser crimes. And if I right click and go to attribute table, we have, load all, 5,230 crimes now. Okay, so again, got into the more serious ones. We have less points on the map, but still have a good amount, right? We have over 5,000, so that's pretty good. And then this, while we're studying this stuff, let's just look at the neighborhoods one, open the attribute table. And in here, these are based off of, I think they're originally based off of census tracts, with how these boundaries showed up, which are effectively neighborhoods is what we're dealing with here. And we've got way more information that we're going to use today. Information on the size, like we have acres in here with the name of the neighborhood. Oh, and okay, this one doesn't have, we We do have square miles. That'll be useful. This one doesn't have any of the population information. Maybe there's another thing in that tutorial I saw. Okay, so it's just the neighborhoods themselves. That works. We're cool with this stuff. So that's what we got. Let's go ahead and hit save. Now let's get back into some of the educational component here. So we have, when we're dealing with any data, but like point data, like what we're looking at, we've got two key terms. I don't even think Boba in that crime analysis book really gets into it. This is more kind of nerdy geographer stuff and a certain kind of geographer, but there are two terms. There's spatial dependence and then spatial autocorrelation. Okay, two connected but separate terms. So spatial dependence refers to how, these points here, how one point influences the point right next to it. Right? And it ties in with Tobler's law. I think I talked about it maybe in the last video. I got into this stuff. But the idea that things that are closer together are more similar than things that are farther apart. Right? Now that, I have my issues with that. I think I mentioned how this modern technological day, that gets challenged more and more with, internet and Zoom stuff and all of that, at least from a human or societal standpoint, but also when it comes to just, physical reality, being there in the place. Yeah, there's some relevance to that, especially with physical, natural phenomena and all that. But that's the idea with this whole spatial dependence idea, is that things are spatially dependent on one another in the sense that like or close things influence each other. And so when we think about like criminal data, it's the idea that you're going to have more crimes taking place next to other crimes, right? Or if we're in some dangerous part of town, that's where crimes are going to take place. And if you're in a safer part of town, you're not going to have as many crimes taking place, right? That's the idea. That's kind of a hypothesis at this point. We don't know. We're going to see if there's any, connection to that or whatever. But, maybe crimes are simply random. Maybe they're evenly dispersed. There's, no true clustering going on. Who knows with this stuff? That's something we want to test. We have our ideas about it, but that doesn't always, transfer to reality, right? What's actually happening. And so that second term, spatial autocorrelation, connects to spatial dependence. And it's basically, it's a statistical test to see if that is actually happening. Okay? And so we would say something has positive spatial autocorrelation when you see that neighboring things are similar, right? That the closer things are together, they're more similar in their values, and the further apart they are, they're more different. Negative spatial autocorrelation is the opposite, where there is no clustering going on. You don't have these neighboring things exactly like one another. And it can be, just truly random. It can be evenly dispersed. Like one example is a checkerboard would have this negative spatial autocorrelation because things that are right next to each other are actually different, right? With the alternating colors on a checkerboard. So a few different ways things can have that negative autocorrelation. But that's something we want to test as we're working with this stuff, right? As we're trying to see what's going on. We first want to just look at these points and go, is there any, autocorrelation? Is there some spatial dependence at work here? And luckily, we have a tool, right? We have the ability to get in here. So go, I'll go this way, analysis tools. Let's go from here. So go into your main tool thing. And we want that spatial, let's see, there we go. Spatial autocorrelation, global Moran's eye. Here's the first of some of these we're going to see. These statisticians, these people, like Moran, it's somebody's name. A lot of these things that we have, there are individuals who, or a group of people who came up with the tool, the actual math behind stuff, and so that's what we're doing here. So I don't know who Moran is, but some of these, as you work through this, you start to know, like, oh, I met that guy, which is kind of cool. But one thing that drives me crazy, and with some of these people, if I ever meet them, I want to get at, like, eye. Moran's eye. Why it looks like one, number one. I think really all of this is set up, just like if you're part of the in crowd and you pronounce it properly, right? And if you're a newbie at all this stuff, you'll say, Global Moran's one, and everybody laughs at you. That's my fear. That's my own issues I have. Yeah, so it's pronounced I, just so you know. But this is the one we want. So I'll left click on that. We'll see at least one more of these where it's just kind of weird. But what this is going to do, I'll pad as this is loading up. It's cold this morning. Everything is slow, including myself. But what this is going to do is we're going to say, hey, check out this data. Do all your incredible, math to actually test this, but let me know what's going on in terms of spatial autocorrelation. Are these things clustered together where there are like values in one area? And, as you get further apart, it kind of spreads out. Is it evenly dispersed? Is it random? Like what's up? And based on this, if we get that, yeah, there's actually some clustering going on, or there's something at work, then that's kind of a signal that we can continue forward. There's stuff to test, further things to do, right? If it's just completely random, there's not a lot in terms of spatial statistics and all that we can really do because it just seems to be random, right? So that's what this is. This is a good first step when you've got point data like this that you want to analyze. So input feature class, we're going to do crime offenses. And it says use the filtered records. Exactly. That's what I want, right? Because we did that definition query. If I didn't want that, I just click this to uncheck it, and it'll look at all, 11,500 records. It'll study all of them. For this, I'm just interested in these serious, severe crimes for what I'm doing. So I'm going to leave it like that. Input field down here, there are going to be some numerical things going on. I'm going to select hierarchy right here. And it's a case where you need to have some kind of value that's, being checked here. It'd be nice to just kind of have, it's a crime, or they physically clustered in an area, but it wants something. The hierarchy thing will work for what we're doing. And it's a case too with, like, say we were looking at pollution, and it's, think with this, I'd actually like it if the numbers were flipped, right? So like if murder, instead of being 1, was 8 to kind of give it a weight, but whatever. But like with pollution values, that would be a good thing. However many parts per million of whatever nasty chemical you're finding, it can base it off of the amount of something. Okay, so that's the idea there. With this, this generate report thing is it's silly. I always check this. It comes unchecked, but give me the report. Tell me what is going on. We'll see this little graphic that it gives you. Very helpful for what we're doing. So always check that stuff. The other thing, and this is a key thing here, we have this conceptualization of spatial relationships. This gets kind of deep. In here, you've got inverse distance squared, fixed distance band, zone of indifference. I love it. Just some of these names are fantastic. But what this is getting at is effectively how do we treat where these things are in space? Okay, that's the idea behind it. Is does it matter what else is around them? In some cases, this one, this inverse distance and the inverse distance square, like these are good for natural phenomena, things like elevation and temperature and stuff like that, should work for this. Other things, in fact, we don't have, there's some other ones when we get to the polygon stuff, you'll see that really treat it more like actual neighborhoods. That's one thing we're going to get into later on. With all this, you can, let's see if I click here, this little eye gives you some information. It's telling you, what these things actually do. It's a case where, you read through this, it might make it more confusing than not. Yeah, okay, we don't have it in here. I thought there might be a link to the actual help thing. But you can Google this conceptualization of spatial relationships, get more info from Esri's website. But also, you do a little Googling, you can see there are people who put resources up there to help you make sense of it. Some YouTube videos, some tech stuff, where they say like, yeah, if you're studying something like this, inverse distance is good. Or no, use that zone of indifference or whatever. Okay, we're just going to use inverse distance right now. From what I've read, it should work with this. In fact, we can test it a few different things just to see. This distance method, we have Euclidean and we have Manhattan. And what Euclidean is, it's the, any direction, right? It's an as the crow flies kind of thing. I don't know if that's too old a phrase, but it means that if I'm, measuring from this point here to this point here, it's just a straight line, right? That shortest distance. Manhattan is like the city itself. It follows blocks and like angular things. So if you were doing some kind of like traffic study, Manhattan would make more sense, right? In this case, Euclidean is going to be fine. This stuff is going to be fine. The distance band, I'm just going to leave that blank, let it do its thing, hope for the best with some of this stuff. And if I were, I've read some of this stuff in the past. I've looked things up. But honestly, if you're doing this, if you've been given this task by, say, you're working for a county agency, city agency, you're not actually somebody who majored in crime analysis, but you're doing some special project, do the research, right? Spend an hour just reading through things, making sure, so that when you get questioned on what you did, you can say, oh no, I did inverse distance Euclidean, with its distance method, because, this study, by this group of researchers, that's what they did. And they found it to be the best one, right? Or I did, zone of indifference or whatever. The sad reality is there's a lot of this that's here, and a lot of people don't question it and just kind of go with it. And to be fair, some of these defaults that are given, there's a reason for that, because they work very well. So with that, sometimes it's fine, but it is kind of scary to think about some of this analysis that we do that's, there are big consequences behind it in terms of, an allocation of resources, from, government funding to more patrols and potentially, locking more people up and sending them to jail and stuff like that. Kind of a lot of responsibility on our part to do good work initially, so we're not wasting money. We're not, not being the weak link in having society operate, right? So read through this stuff so that you know it. But this is good from what I can remember. But we'll try a couple here. So go ahead. Once you have it like this, you hit run, And if that generate report is checked, when this, it says writing HTML report, updating, oh, and it gave me a warning. I think it's the distance. Yeah, that default neighborhood search threshold was 3,100 feet. It's telling you, this is what we picked. You didn't specify anything. This is what we did. I'm cool with it. But the big thing down here is this report file. It's saved in your project folder. So you can find it if you need to, but you can just left click on it right here. And it shows you this graphic to kind of help you out, as well as gives you some actual, some numbers and all of that. And reminds you if it's been a while and you're coming back to it, which feature class we're talking about, what we did, and all of that. But what it's saying, this is all based on like the z-score right here. And the z-score thing, it's important in statistics. It's something that, a million years ago, I could rattle off exactly what it's doing and all of that. I can't remember. I can go back and look it up. This is what's nice about ArcGIS is it does the math for me, and it's telling me, it really dumbs it down for me. Look, man, this is clustered, right? It's saying there's something going on here, right? In terms of spatial distribution, these crimes demonstrate this clustered pattern. Okay, there's some positive spatial autocorrelation going on right here. Dispersed is also can be valuable. There's kind of a pattern to how spread out it is. So there's something there too where we can continue to study that. The worst is when you get random, where it's saying like, yeah, it's not spatial. Is it effectively what it's saying, or there's no clear, based on what you've given us, there's no clear spatial pattern to what's going on. So it's where GIS isn't that wonderfully useful. But in this case, what this tells me is like, yeah, go ahead, continue to play around with some of this stuff, right? So I'll close that, and then really quickly, before I end this video here, and we'll have another one where we get into actually doing some of the analysis, but let's just try one of these other ones. Let's try the zone of indifference, right? I'll leave everything else the same. I'll run it. And this is really going to suck if it says, oh, it's random. Well, then I'll stop the video and I'll do a little researching. And the next video will be much more informed with these things. Let's see, it's thinking. But my prediction is that it will also say it's clustered. The z-score will be different. But I think, wow, this is really, there's tension. You feeling it? It's ticking down. It's like in those movies where they're trying to like copy the file, and the bad guys are coming in, and that blue bar is slowly creeping forward, and the shots are going from the bar to the bad guys to our hero who's sweating and all that. Almost there. Okay, there we go. All right, let's check this out. Warning. Exceeding warning. Okay, so we got some bum records. Interesting. But it's not a majority. There's a lot. It got tired. But let's click here. Clustered again. Right? Z-score a little higher from what I remember. But yeah, still showing that it is clustered. So we can move forward. So with that said, I'll stop the recording here, but now we know there's something going on with our data. In the next video, we'll actually get into some of these statistics. What can these crimes tell us? So I'll see you in